Find the surface area of the pyramid. So to do this, it's probably easiest to think about this by using the net of the shape. So just a quick sketch. The net of the shape will be made up of a square base, 7 by 7, and then it's going to be made up of these triangular parts, each face being the same, that would come off here kind of like this. I did say it was a sketch. So all we need to do is work out the area of each of the bits, which isn't too tricky. So the area of the central bit, this is a 7 by 7 square, in the middle, say 7 times by 7 will give me 49. So the area of the central part must be 49. Put the units on in a minute. And this bit here is a triangle, and the triangle is just a half base times by height, and I know both of those. So it's a half of 7 times 9. 7 times 9 divided by 2. 7 times 9 is 63, half of that's 31.5. We'll discuss in a minute why I didn't need to bother halving it, but 31.5, so each of those triangles is going to be 31.5 because it's a regular pyramid. So 31.5 plus 31.5, which is why I didn't need to half it, because that's just going to take me straight back to 63. And then I've got another 2 of those. So in effect I've got 4 lots of 31.5 or 2 lots of 63. So I've got 126 for all of the triangles put together, and I've got 49 for the square bottom part. So when I add those together, that gives me 175. And now I'm going to put the units back on the end, which is square inches in this situation. Find the surface area of the pyramid. Similar kind of question here. We've got a regular pyramid with square base, but this time we've been given the vertical height of the pyramid rather than what you call the slant height, which is the height of each of the triangles on the outside. So we need to do a bit of work to work out that actual slant height, because we need that to find the area of the triangle. So to do that, I'm just going to draw a little line out from the centre to the edge of the pyramid, its base. We know that it must be a right angle in the centre here, and we know this distance vertically is 12, and because this is the centre, this distance from the centre to the outside must be 5, because it's just half of 10 along here. So if we're wanting to find this distance here, the slant height, then we can just use Pythagoras to work out that length there. So the slant height, which we'll call x for now, is just going to be 12 squared plus 5 squared. So using Pythagoras, that's 144 plus 25, which is 169, and square root of that is 13. So the slant height, the value of x, is 13. So now we can put it all together. The base of the triangle is 10 by 10, so that's 100. Each of the triangles, of which I've got 4, is going to be half base times height. So the base is 10, height we've just worked out is 13, so it's going to be 10 times 13 divided by 2 for each triangle, but I've got 4 of those in effect. So 10 times 13 would be 130, half of which is 65, but I've got 4 of those, which will give me 260. So the surface area of the whole shape then, when I add those 2 bits together, will be 360, and the units here are square feet.